Drumming. Whether it's the steady beat of the drum line or the harmonious melodies of the marimba, all percussion instruments work because of the underlying physics concepts we will explore today. Hi, my name is Isaac Frank, and I'm a percussionist at Naperville Central, majoring in percussion performance at the B&N School of Music at Northwestern University. I first became interested in this topic when I wanted to know more about not only how drumming works and how it relates to physics, but how I can improve my drumming with the knowledge of the 5 physical concepts we will explore today. Concept number 1. Wave dynamics. This is a concert bass drum, which, when played at regular speed, makes this sound. However, when this footage is slowed down, we see a completely different effect. One can actually observe the waves that are propagating back and forth upon the drum. This demonstrates for us the concept of wave movement, that when a surface is struck, the energy is transferred from the mallet into both sound energy and energy into the head itself, causing the waves to move away from the source of force. Concept number 2. Metallic properties. We see a relatively similar concept with cymbals. However, you can see that the actual metal on the cymbal bends when it is struck by a mallet or a stick. This demonstrates the concept of pliability in materials that the cymbals are made out of to allow the cymbals to resonate and produce the loud sound that they do. You can see at the moment that the cymbal is struck with the mallet, there's actually an indentation into the cymbal, though the metal itself is not actually changed. This pliability gives it the loud sound that allows it to reach across the ensemble as it does. Here, that same effect is demonstrated with crash cymbals. Concept number 3. Drum size versus wavelength. Here's the video of the large bass drum that we saw earlier. Notice its relative resonance. To contrast, here is a snare drum, a much smaller drum that has a much tighter head. We see that the wave properties we previously saw are now restricted as size decreases. In addition, pitch also increases as the size of the drum decreases, and as a result, the waves on this small drum are much smaller and much harder to notice than that on the big drum, as they are of a higher frequency than the ones that were on the large bass drum. Concept number 4. Resonance. A marimba consists of not only marimba bars, but resonator tubes beneath the bars, shown here in the picture, that help the sound resonate. Even though the tubes shown in the picture have holes in them and are hollow, the ones beneath the bars are filled at the bottom, and they allow the sound to resonate. The sound from the marimba emanates in all directions, mainly downward due to the shape of the bars, which we will cover later. And the resonators help to bounce that sound back and amplify it upwards and outwards so as to establish as much constant sound in the same direction. This helps to bounce back the sound in an upwards direction to keep it from flowing into the floor and away from the listeners. Concept number 5. Marimba bar design for wave interference. You may have noticed that the marimba bars are not just solid blocks of wood, but are shaped so as to maximize frequencies across the bars. This design is engineered so that the waves do not interfere with one another destructively, but rather constructively, so that the relative harmonic frequencies act together as one and produce a single unified sound. Thank you so much for watching, and join us next time on How Stuff Works.